Welcome gentlemen. I am here with a new presentation. That is one favorite topic, that is the governor. Well, let's talk about a simple governor. What it does, the function of the governor is to regulate the speed. Some important points which I want to share with you, I will speak about, which the reader find it useful, or sometimes he might overlook or not look at those points which are very important in the design of the governor. I have drawn a very basic drawing of the governor. These are the flywheels and this is the gear which is geared to the engine shaft. I have also drawn the different arrangements of the how the oil is taken and given to the cylinder which controls the fuel rack position. I have drawn the pump. This is the gear pump. It is 2 gears and it is taking oil from the sump of the governor and it is giving to the pilot cylinder. Now the pilot cylinder is connected to 3 points. That means what? This is one point. This is one point. This is one side. This is the other side to the sump. This is from the pump. This one is coming from the pump. And this is going to the cylinder which controls the fuel rack. You can see this is the pilot piston or pilot valve. So here what happens? The oil from the sump is taken and given to this. It is already always available at this point from the upper side of the pilot valve. When this rod which is connected to the spring loaded arm, when it goes down, what happens? This piston goes down and a connection is made between this part and the pump pressure part. So the oil from the pump goes from here to the cylinder and the cylinder is pushed more and fuel rack is increased. That means when it will happen? When the flywheels come closer. When it will happen? When the RPM decreases. That means when the RPM decreases, the flywheels will come closer and this pilot valve will come down. And a connection between the pump's part and the cylinder connection, it will be made and oil will be given to the cylinder which increases the fuel rack. When the RPM is maintained at that point, where this oil is going, because pump will be pumping at all points, at all times. So where this oil has to go? Now this oil has to go to the sump again. Whenever the oil is not consumed, it is present at this point. That means when the RPM has been maintained, the oil has to be consumed, oil has to go somewhere. So at that point, the oil comes back to the sump at this point. And consider the case, the RPM has increased. So what will happen? The RPM is increased, the flyweights will fly out more and it will raise this rod. This rod, they will raise this rod. And what will happen? A path will be, connection between the cylinder and the sump is made. RPM of the engine is increasing due to any reason, due to load coming down, then the flyweights will fly outwards. And what will happen? This piston then, this pilot valve, it will then go up. And what will happen? There will be a connection between the cylinder and the sump. And in that case, the oil from the cylinder, as it is spring loaded, the spring loaded piston cylinder will release some oil from it and it will drain to the sump. Till the time the RPM has been reset to the setting of the needed RPM, and at that point it again comes back and closes the port. This pilot valve will close the port, and again at that speed the engine will keep on running. So one thing is notable is that point number 1, we must not forget that this relief valve is, spring loaded relief valve is needed. Why? Because if the RPM of the engine is maintained, then where this oil will go? The oil that is being pumped, it has to get a path, because at steady RPM, this oil will be, this path will be pressurized. So there must be an arrangement for the oil to flow. So this spring loaded relief valve is here connected, and this spring loaded cylinder is so set that the oil can flow easily to the cylinder, then to this path. That means the setting of the spring loaded valve here, setting of the relief valve will be more than that of the what is required to pump this cylinder. Otherwise, instead of the oil flowing to the cylinder, it will keep on flowing in this direction. So the setting is little bit higher than the resistance that is met here. And point number 2 is that we are using a conical spring here. Why this conical spring here? Why not a normal rectangular spring like this? The reason is that if we use a normal rectangular spring and this spring is pressed up a little bit, the spring becomes stronger, and at this pressed up position, as the spring is stronger, now the value of the spring constant changes. That means at that position there will be a greater amount of force needed to bring a change in the elongation of the spring. That means the linear connection of the RPM and the spring decompression will be lost, which is possible when and only when we use this conical spring. In this conical spring, it has been seen that at all times the spring constant remains the same. That is why we use the conical spring. So at every point the same amount of force is required to bring a change in small elongation, which is very much essential to design the governor. And the other point is that we can see that the oil is coming here and present with full pressure here at the pilot valve. So there is every possibility that the force, the pressure of the oil, it will force it down at all times, and thus the oil will be flowing to the cylinder at all times. So what to do? A hydraulic balance of this rod has to be arranged. That is why another surface, another face in the opposite direction is made. So the force acting in upward direction is also the same as the force acting in the downward direction, because the areas are same and the pressures are same. So if the areas are same, the force acting in the both direction will be same, and the net force will be zero, and the movement of this rod will be nil. So that is one more point to note. And one more point is notable is that the some oil, it has to be maintained at a particular level, because there are a lot of reasons that the some oil, as it goes on rotating between the pump and the sump at maximum time, it goes on increasing in its temperature, and the volume also goes up increasing. So if we do not give a certain amount of empty space in the sump, then the increasing volume due to the increasing temperature, it will affect the proper functioning of the governor. That is why a level gauge is given which we are supposed to maintain the oil so that some empty space is always there. And this is the connection of the basic governor. So this is a, so what are the parts? These are the flywheels, this is the conical spring, this is the gear, this is the pilot valve, this is the pilot valve, this is the spring loaded helical, this is the gear pump, this is the oil sump, and this is the cylinder for the fuel rack, maintaining the fuel rack. This is going to the fuel pumps. This is in increasing direction and this in the decreasing direction.